Um, Good day, everyone. So, we are here now to discuss about the number system and codes. So, in the book, Digital System Principles and Application, edition by Neil S. Whitmer. So, to give you idea, before it was Ronald J. Tocci is the main author of this book. I have this book, 10th edition. Okay. So let's start. So these are the objectives of our lesson today. Convert the number from one number system, decimal, binary, hexadecimal, and vice versa, to its equivalent in one of the other number systems. Then cite the advantages of the hexadecimal number systems, count in hexadecimal, how to count. No? So most of us knows how to count in decimal. No? The symbols are 10. No? So meron siyang 10 symbols, 0 and 9. So after 9, it will reset to magiging 0, but yung second digit mag-initiate sa 1. And so on. But the hexadecimal, so there are additional 6 characters, no, for hexadecimal. So then we will represent decimal number using the binary code. Okay, may mga pros and cons tayo i-discuss about the binary coded decimal or the BCD. Explain the difference between the BCD and the straight binary. So the BCD is not binary. So that is meron difference between the two. Explain the purpose of alphanumeric code, such as the ASCII code. No? Then explain the parity method for error detections. No? So as of the moment, dito sa chapter 2, explain lang how in our topics sa networking, meron yung talagang methods, no? Okay, technical, no? For error detection. Then lastly is determine the parity bit to be attached to a digital data string. Okay, so ready? Sayang it's not face-to-face, but I see to it that you will enjoy, this video, this recorded video for our topic today. Okay, so let's have the binary to decimal conversion. So convert binary to decimal by summing the position that contains A1. No? So we have a value of 1, 1, 0, 1, 1, no? 1, 1, 0, 1, 1, binary, then how to convert that into decimal. So as you notice, siyempre, yung natawag natin power of 2, but so style ko dyan is bilangin natin yung number ng binary, how many binary bits that the given has, have. So we have 1, 2, 3, 4, 5. So 5 minus 1, that's 4. So ang pinakamataas is 2 to the 4. Then the next is 2 to the 3, 2 to the 2, 2 to the 1, 2 raised to 0. Yeah. And then since that this middle is 0, so any number, let's say 2 to the 2 is 4 times 0. So that is 0. So whatever here, value that you have here, multiplied by 0, that's 0. And then so but you have to add the power of 2 that has a 1. So 2 to the 4 is 16. No? 2 to the 4 is 16. Then we have 2 to the 3 is 8. 2 to the 1 is 2. And 2 to the 0, any number raised to 0, that's 1. And then you add it, then you have the decimal. So 27 raised to 10. 16 plus 8 is 24 plus 2, 26 plus 1, that's 27. Okay. So next, let's have another example. Let's have greater number. So for greater number, greater the number of the bits that you have, or the binary bits that you have. So here, bilangin natin 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1, so the highest is 2 to the 7. Okay, so gawin na lang natin yung 0 yung 2 to the 6, 2 to the 5, 2 to the 4, and then 0 yung 2 to the 3, 2 to the 2, 0 ang 2 to the 1, and 0C, 1C, 2 to the 0, kasi naka-1 pa. Okay. So itong mababa rito, that's just how we determine the what kind of number system the given has. And but pagka decimal, pag wala, that is default as decimal. Pwedeng meron, 10, pwedeng wala. But si binary, kailangan merong 2 yan. Si hexa, meron pang ang octal. But we will explain it siguro sa mga susunod nating lessons. Then, so when you add 2 to the 7, that is 2 to the 4 is 16, 32, 64, 128. So this is 128, plus 32 plus 16 plus 4 plus 1, that is 181 base 10. Okay, so next, pwede nyo mag-i-post, i-repeat kung di nyo naintindihan. So next we have that's one method. Let's have the double-double method. Avoids addition of large numbers. So how to do that? Write down the leftmost one in the binary number. Double it and add the next bit to the right. Then write down the result under the next bit. Continue with the 2 and 3 steps until finish with the binary numbers. So ito yung double-double method. So 1 times 2 is equal to 2 plus 1 times plus 1. So this is 3. 3 times 2 is equal to 6. Then plus 0. So that becomes 6 times 2 is equal to 12. Plus 1, that's 13 times 2. Okay, is equal to 26. Then plus 1, so that's 27. This is the double-double method. Okay, so binary to decimal conversion. So let's have the reverse process that we described a while ago. Note that the all position must be accounted for. So let's say we will have a given number of decimal, let's say 45. Then how to do it? Okay, so the style is how I got it, and I'll explain it. So explain ko yan. So meron tayong given na 45. So mag-stop share ako. I'm hoping na nakikita nyo yung aking paper. So the given is 45. So think of a power of 2 that is equal or lesser than 45. So ano ba yung mga power of 2? 2 to the 0 is 1. 2 to the 1 is 2. That's 4, 8, 16, 32, 64, 128, 256, 512, 1024. This is 2 raised to 10. No? So 2048, 4096, 8192. No? So 10, 11, 12, 13. Ano? So may ito para mas mataas pa yung 16,384. No? So actually hanggang sa ganyang number kaya natin mag-convert ng decimal to binary. So think of a power of 2 less than or equal to 45. Hindi pwedeng 64 so 32. Then you minus the 32 to 45. So we have 3 then 1. Then think of a number or power of 2 less than or equal to 13. So that is 13, hindi 16, so si 8. So minus 8, so magiging 5. Tama ba? So think of a power of 2 less than or equal to 5. So that's 4. Minus 4. So that's 1. Think of a power of 2 less than or equal to 1. So sakto na siya, 1. So when you convert it into binary, ganito naman. So mag-start tayo sa 2 raised to 0. Meron bang 2 raised to 0? So meron. Walang 2 raised to 1. Merong 2 raised to 2. That's 4. Merong 2 raised to 3. That is 8. At merong 2 raised to 4. Walang 2 raised to 4. That is 16 kasi. Pero merong 2 raised to 5. That is 32. So that is 101, 101 binary, no, base 2. Okay. So mag-share ako ng screen again. Yan. So tama ba tayo? Kung the output is 101, 101 base 2. So tama tayo. So let's have another example. Medyo mas malaki. No, 76 daw. No? So yan, 64. So 76 minus 64, that is 12. So plus 8, di ba? And then 12 minus 8, that's 4. So sakto na siya. So 64 plus 8 plus 4. So ganito mangyayari, no? So walang 2 raised to, walang 1, walang 2, may 4, may 8, walang 16, walang 32, pero may 64. Okay ba? Plus. Let's have bigger number. Ano pang mas gusto nyong bigger number? Pwede natin i-solve. Papakita ko sa inyo na that is parang very simple in this method, ano. So let's say 1, 4, 3, 4, 4. Parang I love you very much. So think of a number or power of 2, sorry, rather, that is less than or equal to 344. No? 14,344. So ano 'yon? So 'di ba meron na tayong 2 raised to 10, no? Is equal to 1,024, 2,048, 4,096, 8,192, 16,384. So sobra na siya, di ba? So I think ito siya, no? So this is 8,192. Okay? Then i-minus natin siya rito. 8,192 i-minus natin. So this is 4. And then this becomes 2 and this is 14. 14 minus 9 is 5. 2 minus 1 is 1. So 14 minus 8 is 6. So 6,154. So nasan siya dito? Hindi na pwedeng 8,192. So meron siyang 4,096. So meron siyang plus 4,096. So then ma-minus natin si 4,096. That is 2 raised to 12, no? So this is 8. So this becomes 4. So this is now 5. Then sorry, tama, maging 4 to. Then ito magbabaro din, so 0, then 2. So plus now 2048, so pwede. So 2048 kasi 2058 to. So 2048. So I think magiging 10. So that will be plus 8 plus 2. Plus 8 plus 2. Yan yung magiging power of 2's natin, no? Galing dito. So ganito yan, ha? So walang 1, may 2, walang 4, may 8, walang 16, walang 32, walang 64, walang 128, walang 256, walang 512, walang ulitin nga natin dito sa baba, mukhang ano maano tayo, no? So walang 1, may 2, walang 4, may 8, no? May 8, walang 16, walang 32, walang 64, walang 128, walang 256, walang 512, walang 1,024, pero merong 2,048, merong 4,096 at merong 8,192 base 2. Okay? So yan medyo mas mataas. Kaya ko hanggang million. Actually, 2 raised to 20 is 1,048,576. So kabisaduhin nyo na yon, lalo na kung you want to go into digital system. Okay? Power of 2. Let's have a repeated division. So in the repeated division, sorry, mag-share pala ako. Hindi ko alam kung nakita niyo to, no? Sorry, yan. Sa recording, parang nawala yata. Okay. Ulitin ko, no? So 14,000 less yung power of 2 na less than or equal, that 8192, no? Tapos minus ko, ano naman yung less than or equal na power of 2, 4,096. So minus ko, maging 2,058. And then ano naman, so 2,048. Okay, so minus ko 10. Okay, so siyempre 8 plus 2 na lang yan. So then walang 1, may 2, walang 4, may 8, walang 16, walang 32, walang 64, walang 128, walang 256, walang 512, walang 1,024, may 2,048, may 4,096 at merong 8,190. Okay, so ano ko muna yan. Let's have let me share the lesson again. Okay, so this is a repeated division naman, no? Okay, so for the repeated division, divide the decimal number by 2, no? That's the first step. And then write the remainder after each division until a quotient of 0 is obtained. Then the first remainder is the least significant bit, no? Yan. Is the least significant bit, pinakahuli. Yan yung first. Kasi when you divide the 2 in any number, the only remainder is only 1 and 0. Diba? So whatever the answer, that's the least significant bit, no? Then the last is the most significant bit, no? So ito, divide 25. Let's say the given is 25. So divide mo sa 2. This is other method, no? So that's 12, remainder 1. So then 12 divide mo sa 2, that's 6, remainder 0. 6 divide mo sa 2, that's 3, remainder 0. 3 divide mo sa 2, that's 1, remainder 1. And 1 divide sa 2. Pag nag-0 na, stop ka na, then the remainder is 1. And the 1 is the most significant bit, no? And the answer is 110011 or read up. That's the other method. Okay, next, repeated division. This flowchart describes the process and can be used to convert from decimal to any number system. Actually, pwede siya sa octal, pwede siya sa, siyempre, divide mo sa 8. Pag decimal, divide mo sa 10. Kapag naman, sorry, decimal na pala yan. Pag hexadecimal, divide mo sa 16. Okay? Pero ako, ang ginagawa ko, if you look at this, madali lang, let's stop share para makita niyo itong aking, no? Ang ginagawa ko, okay, so, aanin ko, kopyahin ko, 11100000001 no? Pag octal, di-divide ko to sa tigta-tatlo. So, and then, siyempre, dapat kabisado natin yung, ito na, let's say, ito, this is 2. This is 1, this is 0, this is 4, and this is 3. So, 3, 4, 0, 1, 2, base 8. Pero pagka decimal, hexadecimal naman, no? So, ito naman, i-divide ko sa 4, no? 4 naman. Okay? And then dapat kabisado natin. Ito mamaya papakita ko yung table. So this is 10. Kaso sa hexadecimal, 10 is A. No? 0. This is 8. No? And this is 3. So 380A base 16. So ito yung kanyang, ganyan lang ka. No? Pero, syempre, yung itong flowchart na to, pwede rin natin siyang gamitin. Okay. Let's have okay. Convert 37 to binary. So, yeah, no? Divide sa 2. So, remainder is 1. 18 divides 2. Remainder is 0. 9 divided by 2, 4.5. Remainder is 1. So, 0. 0, then pag 1 divided by 2 is nag-0 na, but remainder 1, this is the most significant bit. So pataas. So the answer is 10010 pagka 37. Parehas din yan doon sa example natin kanina. You can go back. Okay, so syempre in a hexadecimal allows convenient handling of long binary string using groups of 4 bits, base 16. Yun ang sinasabi natin. So, 4 bits, 4 bits, 4 bits, 4 bits, 4 bits. So, pwede mo nang alamin kung 16 times 16 times 16 times 16. So, yan yun. No? So, pwede yan. Then, pagka naman after na hexadecimal point, not decimal point, not binary point, but this is a hexadecimal point because this is hexadecimal. No? So, ito naman, pa-negative naman pagka merong decimal places. No? So, the relationship between the hexadecimal and the decimal and the binary numbers are here. Ito, kaya sinabi ko dapat kabisaduhin ito. Ang binary. Madali lang naman eh. So, 1, 2, 3, 4, 5, 1, 0, 1, 5, 1, 1, 0, 6, 0, 1, 1, 1, 7, this is 8, 9. Pag 10, 10, 10, ano? Tapos A yon sa hexadecimal. And so on hanggang F. Pagka 1111, that is F. Pagka naman 16, 10000. Okay, but ito lang mga kabisado nyo, medyo mas mabilis na kayong mag-convert. Okay, so let's continue. Convert from hex to decimal. Ano? Ito yung sinasabi natin by multiplying each hex digit by its positional weight. So actually 356. 356 tatlo. So that is 16 minus 2. Minus 1, that is 16 raised to 2 times 3. So that is 768. No? And then ito yun, no? That is 768. Then 5 times 16 base to 1. So 5 times 16, that's 80. 6 times 16 to the 0. So that's 1. So plus 6. So add mo lang yan. So that's decimal. Pero normally ako, iba ginagawa ko dyan. No, pagka ganyan. Kino-convert ko muna sa kino-convert ko muna sa binary yan. Para sa akin mas madali, Tingnan natin kung parehas ng answer, So mag-stop share ako, 16. Ayan. So ang ginagawa ko diyan para maging decimal siya. So ganito, 3 is 0 0 1 1. 5 by 4. 5 is 0 1 0 1 and 6 is 0 1 1 0. So yan yung base niya. Yan yung base niya. Then ito 1. So magsumot tayo. 1 2 3 4 5 6 7 8 9 10. So wag na natin anuhin to 10. So 10 10 minus 1 is 9. So 2 raised to 9 is 512 plus meron siyang 256. Walang 128. No, but meron siyang ito 25, walang 128. Pero meron siyang 64, sorry, 64. Okay, walang 32. Okay, pero meron siyang 16. No, walang 8. Merong 4, may 2, tapos walang 0. So pag inad natin lahat yan, so tignan natin. So 5, 12 plus 2, 5, 6, that is 8. Then 6, then 7, no? Ba? And then add natin itong dalawa. Mas madali, this is 6 plus 16, 22. So 64 plus 22, that is 86. So plus 86, so magkakaroon ka ng 4, 5, then remainder 1, 854, no, base 10. So ito na yung pinakasagot natin. And then, tingnan natin kung tama dun sa kanina. Yan, so 854 talaga, base 10. Yung una, mali, akala ko base 10 yun. Base 16 pala. Okay, so let's continue. In the second example, the value 10, itong 10, convert natin into A. So, mamaya, was substituted by A and 15 substituted by F. So, kasi 2AF yan, 2 times 16. Kasi 1, 2, 3, no? So 3 minus 1 is 16 at 2. So 16 raised to 2. So multiply natin si 2 times 16 raised to 2 plus 10, that is A, times 16 raised to 1. And then last is the F, which is 15 based on the table here. 15, no? F. And then yan. Then that is 15, sakto. So you add that, so you have 687 base 10. Okay? So for practice, meron kayong sasagutan, no? Pakita niyo sa akin, class, kung meron kayong pakita niyo sa akin na equal ito tsaka ito. Pakita niyo sa akin solution sa scratch paper. Kahit hindi na bold, hindi na ganito nataba. Kahit ball pen lang, kasi after mong mag-solution, picturean mo and then upload mo dito. So saan natin siya i-upload? Nasaan na ba yan? Yan. So dito mo siya i-upload. Papakita ko, ha. So yan, ito. So yung link niyan makikita nyo sa ating MS Teams o yung sa ating LMS, kaso wala pa kasi dun sa LMS, no? So sa MS Teams muna tayo. Yung link nito. Then lagay niyo yung name nyo, yung last name, and then upload na yung picture. Okay, after mong mag-ano. So pwede mong i-post tong video, then upload mo rito. So meron din siyang mamaya na PP22. Ito yan. By the way, hindi kasi mababaan, ano? Dali lang. Okay? So, upload. So meron yan sa 2, tsaka sa 3. Yan, meron yan. Mamaya, magpa-practice kayo. No? Post nyo itong video if you want, tsaka nyo siya sagutan. And then, then, let's have this. Post, pag tapos na kayo, na-upload nyo na, then tsaka nyo i-play ulit itong video. No? So, ang next naman is to convert from decimal to hex by using the repeated division method using 4 decimal. So, to binary conversion. So, divide the decimal number by 16. So, the first remainder is the least significant bit. The last is the most significant. Parang sa binary din. Ano? Kaso divided by 2. So, convert 42,310. Sorry, mali to. This is 423 base 10. Yan, kala ko 42,000. So, may typo itong lecture. So, 423 divided by 16, that's 26, remainder 7. 26 divided by 16, that's 1, remainder 10. Then 1 divided by 6, that is 0, remainder 1. No? So, this is the most significant hexadecimal. Then 10, convert natin yan sa A. Then 7, sakto lang, base 16. Okay? So, another example, 214 base 10. So, divided by 16, that's 13. Remainder 6. 13 divided by 16, that is 0. Remainder 13. So, 13 is D, and then 6, base 16. Okay. So, next we have leading 0 can be added to the left of the most significant bit to fill out the last group. So, sabi. So, ito naman, ito yung binary, no? 9F2. So, 1001. 4 bits eh. F is 1100. Yung 2, dapat 4 bits. Kaya siya 0010. 10 is 2. So, yan yung ating binary using this. And then, for practice 2, mag-stop muna tayo. Mag-post kayo. Sasagutan nyo rin itong Google form na to. So, PP2. Okay, upload nyo ha. Hanggang 10 MB lang. No? Tapos isang submission lang, kaya dapat sure kayo. Ha? Do not play this video until you finish here. Titignan ko yung interval. Ha? So, yun. Next. So, convert naman from binary to hex by grouping bits into 4 starting with the least significant bit. So, yun yung ginawa ko na rin kanina. So, ito yung given. So, ito hanggang dito is the first group. This is the second group, and this is the third group. Dagdagan mo na ng 0, 0. No, that's 3, 10, that's A, and 6. So, 3A, 16, B, 16. Now, this is the last. No? Yung link nandun sa ating MS Teams, and then sagutan nyo to. Ha? Yan. Pakita nyo sa akin yung solution na equal sila. Okay? So, so convert decimal 378 to a 16-bit binary number by first converting to hex. Mas maganda raw. 178. Yan, 178. Then, tsaka mo convert to binary. So, 178 Pakita natin. Kasi divided by 16. So that is 178. So to binary, sorry pala. Stop share ko. Yan, so that is 178. So it becomes 0, 0, 0, 1, that's 1. 7 is 0, 1, 1, 1. Kasi dapat 4 bits. Then A is 1, 0, 1, 0. So ito yung kanyang binary. So kahit wala na tong tatlong 0. Okay, so let's share again the screen. Yan. Wala kasi yung sagot kaya sinagutan natin. So when counting in hex, each digit position can be incremented, increased by 1 from 0 to F. No? On reaching value F, it is reset to 0 and the next digit position is incremented. So paano ba 'yon? So let's count. Kasi sa stop share ulit, I'm hoping that kita niyo tong aking video sa kong phone. So magka-count tayo ng decimal muna. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, ano? Tapos niyan, that's 10 symbols. Magre-reset daw yung 9, magiging 0, tapos increment ng 1 for decimal. So 11, 12, 13, 14, 15, etc. 19. So magre-reset to and then 0. Magiging 2. And then magiging 21, di ba? Tapos naging 99, let's say. So magre-reset to, magiging 100. So that's how we count the decimal. Pero baligtad naman, iba naman sa hexadecimal. This is how we count it. No? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hindi pa magre-reset. A, B, C, D, E, F. Okay, most significant na to. So, most value na to sa first digit, ano? So, magiging 0 to, magiging 1. So, 11, 12, 13, etc. Naging 19. So, magiging 1A, 1B, 1C, 1D, 1E, 1F, and then reset, magiging 2. No? So, 21, 22, and then 2, 9, ano sunod? 2A, no? And then magiging 2F. So magre-reset, magiging 3. No? So magiging, let's say, FF na to. So magre-reset, and then 1. So ang dami na. No? Okay, that's how we count hexadecimal. Okay. So let's ilista nyo if you have questions. Okay. So o kaya i-message sa Teams. I can baka mamaya I can answer it. Okay. So our next subtopic is the binary coded decimal or the BCD. So tapos na tayo dito, no? So the BCD or the binary coded decimal is widely used, ano? This is a way to present decimal number in a binary form. So binary form. And then it combines features of both decimal and the binary system. Each digit is converted to a binary equivalent. No? So iba yan, no? Parang binary coded, 4 bits lagi din yan. No? Kahit na decimal siya. So iba siya, no? BCD is not a number system. It is a coded lang. It is decimal number with each digit encoded to its binary equivalent. So the BCD number is not the same as the straight binary number, no? The primary advantage of BCD is the relative ease of converting to a form decimal, no? So let's have first example, ano? Yan. 874 base 10 to BCD. So 874, madali lang pagkabisado ng 4. 8 is 100, 7 is 0111, and 4 is 0, 1, 1, 0, 1, 0, 0, BCD. That's how it is coded. No? So ito ang decimal, ito ang BCD. Let's have in reverse. So let's say this is BCD. O convert mo naman into decimal. So gano'n naman. Group mo ng 4. Then kung ano yon, eksakto siya. Okay. So 1001 is 9. 0100 is 4 and 0011 is 3. Okay, so ito yon. Divide into 4 bits and then get the binary coded decimal. Convert this daw to BCD. So divide mo lang by 4 and then you will get the binary coded decimal. So ito BCD hindi to, this is BCD, hindi siya binary. Kasi BCD is not a number system. Pahala malito kayo. Ito naman, nakalagay BCD. So divide mo sa 4. So ito yung decimal niya. Then ito rin. No? Divide mo sa 4. This is sabi dito, the forbidden group represent an error in the BCD number. This cannot be a BCD number. Kasi 1100 is C. C is not a decimal. So this is forbidden. Pag nakakita kayo ng ganito, lagay niyo sa answer ng error. Kasi dapat hanggang 9 lang. Okay, the gray code. Gray code. So paano ba yan? Okay, so explain ko yan. So yung binary number, the gray code is used in applications where number change rapidly. Only 1 bit changes from each value to the next. So let's have a 3-bit binary and gray code. So meron tayong 3-bit binary. 000. Sorry, ano ko. Ito, binary. Binary to. Isusulat ko na lang. Ano yung equivalent gray code niya? So madali lang siya. No? So 3-bit binary. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So this is 0, 1, sa decimal to, 2, 3, 4, 5, 6, 7. No, ayan. Ngayon, this is binary. Binary. Then, ano yung gray code? No, gray code. So ganito lang yan. Yung 000, no, yung 000, para magpa-plus ka lang lagi. So, di ba, 0, 0, 0, no? And then, ang ginagawa natin, i-bring down mo na si 0 dito. 0 plus 0 is 0. 0 plus 0 is 0. So, the 0, 0 na binary is equivalent to 0, 0, 0 gray code. So, binaba ko lang to. Tapos, 0 plus 0 is 0. 0 plus 0 is 0. Paano naman sa 001? Sa 001 tayo. 001. So ganito lang din. Baba mo si 0. 0 plus 0 is 0. 0 plus 1 is 1. Okay? So parang parehas lang siya, no? 0, 0, 0, 0, 0, 1. Let's have 2. Yung 2, anuhin natin 0, 1, 0. Gagawin natin yung gray code. So this is 0. 0 plus 1 is 1. 1 plus 0 is 0. So the equivalent ng, 0, bring down 0. 0 plus 1 is 1. 1 plus 0 pala is 1. Sorry. That is 1. So the equivalent gray code of 010 is 011. O etong 4. Itong 4 naman, Let's have another scratch paper. 4 is a 3 pala, sorry. 0, 1, 1. Gray code, bring down 0. 0 plus 1 is 1. 1 plus 1 is 0. So the equivalent gray code of 0, 1, 1 is 0, 1, 0. C4, 1, 0, 0. Bring down 1. 1 plus 0 is 0. Bring down 0. 0 plus 0 pala, no? That is 0. Then 0 plus 0, that's 0. Pagka naman 0, 0, 1, bring down 0. Then, so 0 plus 1 pala 0. Sorry. Ito na pala. Ano ba yan? Bring down 0. So 0 plus 0 is 0. 0 plus 1 is 1. Okay, yan. Pagka naman 0, 1, 0, bring down 0. 0 plus 1 is 1. 1 plus 0 is 1. Okay. So ganito na to. Sorry, nalito ako sa ibang code to. No? So ang mangyayari niyan, bring down 0. 0 plus 1 is 1. 1 plus 1 is 0. So ito yung pina-plus. Sorry. So 0. Wala na yung ano. So 0, 1, 0. So pag ito, 0 plus 1, bring down 1. 1 plus 0. 1 plus 0 is 1. So 0 plus 0 is 0. Okay, yeah, tama na tayo. 1, 1, 0. So ang gray code naman ng 1, 1, 1, 1, 0, 1 plus is so bring down 1. Di ba? Then 1 plus 0 is 1. 0 plus 1 is 1. O, yan ang 1, 1, 1. Yung 5. Yung 6 naman, 1, 1, 0. Bring down 1. 1 plus 1 is 0. Then 1 plus 0 is 1. Okay? Then last is 1, 1, 1. No. So bring down 1. 1 plus 1 is 0. Then 1. So 1 plus 1 also is also 0. So, okay. So sulat natin. 1, 0, 1 is 1, 1, 1. 1, 1, 0 is 1, 0, 1. And 1, 1, 1 is 1, 0, 0. Gray code. Okay. So let's have next. Ulitin nyo na lang pag di nyo naintindihan. O ano tayo? Mas malaki. Mas malaki. Ganito lang din. Nyari, 1, 0, 1, 1, 0, 0, 0. Ano? Binary. Lalagay natin to gray code. Ano? Gray code. So, ganito lang. Bring down 1. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 0. No? Then 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 0 is 0. Gray code. Ito yung gray code. Okay. So mag-share na ulit ako. Proceed for the next. Yan. Ayan. Ano lang to? Parang block diagram lang. Ano natin? Ginawa. Ano? Okay, saan ba ginagamit yung gray code? Ano? An 8-position 3-bit shaft decoder. So this device produces a binary value that represents the position of the rotating mechanical shaft. Then, summary. Di ba? So, kabisaduhin niyo yan. Kailangan sa mga susunod na ano natin, kabisado niyo na yan. Let's have the byte, nibble, and a word. So a byte is simply a word, a special word that has composed of 8 bits. So one byte is equivalent to 8 bits. So marami yan. Binary numbers are often broken into groups of 4 bits and they call it nibble. Yung word naman is any group of bits that is a word. So dinidefine natin yung word size. So a byte is a word of 8 bits. Unable is a word of 4 bits. So yung computer natin, yung PC, the word size is 64 bits, 8 bytes. Then the alphanumeric code represent character and function found a computer keyboard. 26 lowercase and 26 uppercase letter, 10 digits, 7 punctuation marks, 20 to 40 other characters. So that represent the alphanumeric code na ginagamit sa keyboard. So, and that is normally an ASCII code. An ASCII code is the American Standard Code for Information Interchange. So that is 7 bits. So there are 128 possible code groups. Example of use transfer information between computers, computers to printer, and the internal storage. And ito yung pinaka table niya. So yung letter A, character, 41 ang hex niya, 65 ang decimal. Yan yung see the enter table. O kung hex to, gawin niyo lang binary. Yun yung pinapadala ng keyboard serially sa computer. So binary data code and frequently move between locations. So that's why a digitized voiceover and a microwave link, no? Ayan yung mga digital data. Storage, retrieval of data from magnetic and optical disks. Then communication between computer system over telephone line using a modem. So yan yung mga ginagawa natin. Then sometimes electrical noise can cause errors during transmission. Spurious fluctuation in voltage or current present in all electronic systems. So with all that, nagkakaroon tayo ng error. Okay? So in many digital systems employ methods for error detection and sometimes corrections. So one of the simplest and most widely used scheme for error detection is the parity method. So the parity method of error detection requires the addition of an extra bit to a code group. An extra bit to a code group. Then called the parity bit. It can be either a 0 or a 1, depending on the number of ones in the code group. So there are two parity methods, even and add. So the transmitter and the receiver must agree, so naka-record doon, on the type of parity checking. Even seems to be used more often. So pwedeng add, so pwedeng even. So even parity method is the total number of bits in a group, including the parity. It must add up to an even number. So let's say the binary group is 1011 would require the addition of parity bit na 1, making the group 11011. So yung 1 na yun na color red is the parity bit. So the parity bit may be added at either end of a group. Yung end naman ng group. Pag 111, no? Pagka 111, so kasi this is parang 11, that is parang once add tayo ng 1. Then dito naman, the binary group 11 would require the addition of a parity bit of 1, making the group of 1. So the parity bit becomes a part of the code word, adding a parity bit to the 7-bit ASCII code, producing an 8-bit code. So meron tayong ASCII code na 7 plus 1, so it becomes an 8-bit code. Then when ASCII characters are transmitted, there must be a way to tell the receiver a new character is coming. There is often a need to detect errors and transmission as well. So the method of transfer is either asynchronous data communication. Pagka serial, asynchronous. Pagka naman, serial nga. Pag parallel, that is synchronous. No? So an ASCII character must be framed so that the receiver know where the data begins and ends. So nagkakaroon siya ng parang packet. No? Then so the first bit must always be a start bit, a logic 0. And then ASCII code is sent LSB or the least significant bit first, and the last is the most significant bit. So after the MSB, a parity bit is appended to check for transmission error. So pag hindi nagbago, so no errors. Transmission is ended by sending a stop bit logic 1. And that's it. Parity checking. Okay, so you will see an activity, no, for this day, no. After that, yung activity nyo dapat matapos and masubmit nyo siya bago ng end ng class natin. Okay? So, thank you very much and good day.